So today's webinar is going to be about the next generation hardware. We have a few kind of an agenda of what we're going to be going through today. I'm going to be covering the hardware lineup, the differences between the RT3000 V2 and the RT3000 V3. I'm going to talk about the change in RT range, the new RT500, and then going through a bit about the software and some of the configuration options. So I'm going to start with talking about the previous lineup. As most of you will know, we have the RT2000. This is the 2000 series, low-cost INU, INS, with the capability of outputting over a series of different outputs, and all the I/O is on the red box itself. Then we have our RT3000 V2, our flagship product that is used around the world. And we also have the RT4000. This is our 250 Hz output unit. We also have the Inertial Plus. So this is our large box INS that can also integrate external GNSS signals while having a similar output to the RT2000. We have the RT1003. This is our small form factor for space-constrained application INS. It's not as high-performing as the RT3000, but can still be very useful in certain applications. And then the last bit of our lineup is the RT range. So in this particular case, I'm showing an RT range hunter box. And so this is used for our vehicle-to-vehicle and vehicle-to-lane measurement device. The difference between this one and the target is just the CAN output, and that the hunter does the processing itself. Moving forward, our lineup has actually shrunk quite a bit. We have the RT500. This is our low-cost INS. It's a replacement for the 2000 series, and is very much for entry-level INS users. We have our RT1003. Still, it's for form factor, small form factor, where the space where it needs to go is very dependent, or either you need a lightweight application as well. And we now have our RT3000 V3. So this is the same performance as a V2, can be upgraded to 250 Hz, which is why we no longer have the RT4000 in the lineup. It now also supports RT range calculations, which means the RT range Hunter S is removed from the lineup, and it's compatible with our RT range target box, so you can communicate to another vehicle through this. I will be explaining more about how you can set up with in RT range the new lineup. So now to look at the differences between an RT3000 V2 and an RT3000 V3. In terms of physical components, we have the RT3000 V2 is a large red box, weighs about 2.4 kilograms. It runs on RTBNS firmware and also some boards. And we have the IMU that's inside the box, and the GNSS that we use is 2 single antenna GNSS cards. The RT3000 V3 actually ends up being about 30% smaller volume than the RT3000 V2. We still have the red box, but now the measurements are much smaller in some cases, and so here are where they actually differ. So it's about 1 kilogram lighter, it's shallower and leaner. The length has been reduced and the height has been reduced. But on this system, we're now using a different type of firmware, ECBNS. This is much closer to XBNS that we use with the RT1003. And with this, the board set has been removed, and we've managed to increase the processing power available. The IMU has remained unchanged compared to the A3000 V2, but we now have a dual antenna GNSS card, a single card within the box. And this is one of the ways we've managed to reduce the size of the system. Then going to the physical shapes, we have the same performance between the two systems. But one of the things that has changed, another thing that has stayed unchanged is the position of the mounting points. So the distance between this point here and here remains constant between these 2 points as well. So that means that any system that already has mounting brackets set up for these mounting points can be used to install a new generation RT. Though with the old system, the IMU is closer to the mounting point, while now it's moved forward from there. So that is one of the things to consider if replacing in an installation, the V2 to a V3. Things that have remained constant as well is we have the two GNSS antennas available. The main user cable here in yellow and here as well have remained unchanged, so we still have the same ports, the same wiring, so that will stay unchanged. But what we have now is a secondary user cable for power over Ethernet for the XLAN and two extra Ethernet ports that are both female. And in addition to that, we have the Wi-Fi card that has been added. So the other things that's new in the RT3000 V3 is that we now have the capability to use RT range in one box rather than having two separate boxes. We'll talk about that in more detail soon, but we've actually improved some of the accessibility and usability. So we've integrated Wi-Fi, so we can do some wireless monitoring of the device. We've integrated NTRIP, so that you can receive corrections on the open road much more easily without needing an external modem. And we've added CAN-FD interface. So this is a wider variety of message than normal CAN, and you can choose different settings. And we'll look at that in a bit more detail later. And we've also increased the input voltage range that we accept. So it used to be 10 to 25, and we've increased it to 10 to 50 volts. So cars that have a 48 volt power out we can plug the RT3000 V3 directly to the car. So now talking about the RT range Hunter within the RT3000 V3. In the actual connectivity, we have the same number of Ethernet ports available in the RT3000 V3 with Hunter than we did in the RT range S Hunter, because here we have the two additional Ethernet cables, so one to connect the RT, one for the power over Ethernet, and with this additional user cable we now have the same number of Ethernet ports. We still have the CAN output since it's available on our main user cable, and so we can now output CAN as well. But there are two main differences in using the RT range Hunter with an RT3000 rather than an RT range S Hunter, and that is we no longer have these power to external units, but the most significant difference is we now no longer need the second red box. It all fits within one box. This is an example of how between two vehicles you would have to do the installation. So in the Hunter vehicle we'd have an RT and the Hunter S. We could attach that to the struts, connect them with radio to a base station and Wi-Fi to each other. So we have the RT, Hunter box, strut to hold them in the position, radio to communicate to the base station, and Wi-Fi to communicate between the two vehicles. And the target vehicle could also have a radio, and attached to it is an RT and a target box. With the RT3000 as a Hunter, now in the Hunter vehicle, we no longer need the Hunter S box inside the vehicle. With the target vehicle, you can also use a single red box as an RT3000 V3, the target box. but it also still compatible with the target box. So a 1003 combined with a target S box can all still be used to transmit information to the Hunter vehicle when using an RT3000 V3 with Hunter capability. Though I haven't showed it in this particular slide, the RT3000 V2 can still be connected to the target box and used as a target vehicle. The units that our customers still own today are still can be used for target testing, but now you no longer need the Hunter box while doing the testing because it's included. It's now part of the 3000 box, 3000 V3. Sorry. So the range capabilities have stayed the same. We still can do vehicle to lane measurements and vehicle to vehicle measurements using polygons or points or fixed points or feature points. And multiple sensor points is still available with the change in the hardware. So it's a hardware change, but on software and usability, it has stayed the same. Now talking about the RT500. This uses the same framework, the same frame size as the RT3000 V3, but it is slightly heavier. It also uses ECBNS firmware. So we have the smaller board set and the more powerful processor in there. The IMU has remained unchanged, and we have two single antenna GNSS systems within this box. And so those two GNSS systems is why the weight is slightly heavier than the RT3000 V3. So this is a replacement for our non-RTKINS. So it's the solution on a budget. Combines a high-level IMU with a low-cost GNSS for people who are doing entry-level testing. So it's ideal for vehicle dynamic testing, or brake and coast-down tests, and even low precision slip angle. But with the RT500, it has the same improved accessibility that the RT3000 V3 has. It has the integrated Wi-Fi, it has NTRIP, it has the CAN FD, and it has a higher input voltage range. So now to talk a bit about the software changes. In navconfig, this is how you will be able to see how the Wi-Fi configuration takes place. So you'll have to enable the Wi-Fi interface, and then you can set it as an access point, so like a router. You can choose what the name is, what security you have, and a passphrase. So here I have an example of one. And you can choose what the IP of the gateway of the router and subnet masks are. If you want to connect the system to another network, you'll have to enable the interface, configure the device, and then you can be able to see networks that are around you. So in our particular example, I've selected the guest network here at OxTS, and I've put it to the side here. Once you've entered the password, once it can see that network, it will connect to it. If you have both systems enabled at the same time, it will prioritize being a router before connecting to another network. If you have any questions about this, we can go through it at the end. Now for the NTRIP settings. So in the hardware setup under differential corrections, we now have a section where we can enable the use of the internal NTRIP client. So you'll have to enter a host address. So in this particular case, I've hidden it because it's the OxTS NTRIP caster, but you can choose which mounting point you want to use. What is behind here that I've covered up is actually a username and password. So if you have to validate that you have an account with the caster that you've used. Here is the CAN FD options. So you can now select the bitrate and nominal bitrate that you want to use, and you can also use different sampling points. So once you've selected CAN FD in the drop-down menu, it will add all the extra options that come with it, and you'll be able to select, configure it as you want to use. One of the things that we've enabled in the software is the use of our GXIX mixed mode. So this is where we combine the receiver mode and the GXIX mode, and it will use whichever is best for the situation you're in. So in an open sky motorway environment, it will be using the receiver mode, but if you go into an urban area, into a city or downtown, it will use our GXIX mode, combining the best of both systems. Now in the RT Range software, when you open the system, it will now ask you what type of product you're using, and it will give you the option of choosing the RT Range Hunter RT3000 V3. And it gives a brief description of the setting here to make sure you don't try to enable CAN on both simultaneously. If it's the same message, it will prevent you from doing that. Okay.